So we're now going to talk about how to visualize the word searcher find words method. And this is going to demonstrate the use of some of the Java Streams features to read the contents of the input string and find the various words. Of course, we will also look at the source code, which appears at the link at the bottom of the slide. So this particular method searches for words in an input string, the input string here, of course, being the lyrics for the Do Re Mi song, and the words to find will be the names of the musical notes that appear in that song. In this particular example, every word we look up will be found because we're looking for the words that are in the song, but you can imagine different sets of input that would not have those particular properties. So the first thing that happens is we take a list of strings, which is the words to find, and we go ahead and convert those into a stream. And as you can see here, that we visualize that by showing we have a stream of strings which look different from the list of strings. It's just the elements in a stream. Those are then fed as input using the Fluent interface style programming model into the map intermediate operation. And map is an interesting operation that takes every element that's passed in the stream and applies some behavior to it. In this case, the behavior that's being applied is the search for word method, and we pass that in as a method reference, and that will search for the word in the input string for every element in the input stream. So for every one of these strings, do, re, mi, fa, sol, la, ti, do, or just do, re, mi, fa, sol, la, ti, because we don't have to search for do twice, it'll go ahead and search for that in the input string. What comes as the output of that is going to be a stream of so-called search results. And a search result is a class. Of course, an instance of the class is what will be produced here. And a search results stores the number of times that a word appears in an input string, and it also uses this little inner class called result to keep track of the index where that particular search result was found in the input string. So that's what search results does. Now, a couple things to note here. Map, as I mentioned before, applies the behavior, in this case, search for word, for every element in the input stream, and it'll produce an output for every element, so there's a one-to-one mapping, as we'll talk about in more detail later. And the second thing that map can potentially do, and in this case does, it can also transform the types. So here we're transforming from a stream of strings into a stream of search results. Now, under some circumstances, not this program per se, but under some circumstances, we could end up with empty search results where there would in fact be no match. So what we're also going to do here is we're going to apply the filter intermediate operation in order to winnow out or remove empty search result elements in the string. And the way we do that is we pass in a method reference here called search results : is empty, and then we also negate it. And the negator is just a little helper method that I wrote that takes a predicate and negates the predicate. So remember, filter only lets things pass through that in fact are valid or true, and so this will basically remove empty search results from the string. So under some circumstances, again, not this particular program, we can end up with a smaller set of results from the stream after filtering it. The last piece of the puzzle here is to run a terminal operation, which in this case will be the collect operation. And what collect does is two things. First, it goes ahead and it'll trigger intermediate operation processing. What that means is that it'll start pulling the items through from the source and apply these various intermediate operations to each of the items in a way we'll talk about momentarily. So that's what collect does. It starts everything running. We sometimes refer to streams as being lazy, and that's what we mean. We mean that nothing happens till collect runs. And the second thing we do here is we end up with a list of non-empty search results, and that's because we use the toList factory method, which is applied on the collectors utility class, and this will return a non-concurrent collector that will collect the items in the stream that are not empty into a list. In this particular case, an array list, but it's basically something that can be treated as a list. So now we have a list of results, and then the program will display them in various ways that we'll talk about later. A couple things that are really important to note. You might get the impression from looking at the visualization that the processing works at a row-by-row level, as if it was going from left to right, top to bottom, so one row at a time. That's actually not the way things work under the hood. The way things actually work under the hood is it goes from a column-like perspective, where it goes from top to bottom, left to right. So it'll first start with the first element, and that element will be pulled through the various operations in the stream, terminating in the terminal operation, the collector. So each of these items will be pulled through, and the operations will be performed on them from left to right, top to bottom. And so the reason for doing this is sort of twofold. Number one, it's more efficient, having to do with a reason called integrated layer processing, which we'll talk about more when we get to Java parallel streams. And the second reason is to support so-called short circuit operations. And a short circuit operation would be an operation like limit, where you say, I only want to take the first n elements. And so by doing it this way, going from left to right, top to bottom, then we can ensure that as soon as we've hit the nth item, we stop. Whereas if we did it from top to bottom, left to right, we do a lot of extra processing when short circuit operations are involved. And we'll see later when we talk about different types of short circuiting operations. There's short circuiting intermediate operations like limit or take while or drop while. And there's also short circuiting terminal operations such as find first or find any and so on. And we'll take a look at all those things later. So that's the end of the visualization of the find words method in the word searcher class. We'll, of course, take a closer look at the source code here shortly.